What's up, everybody, and welcome back to another video on SAT Math from the Scalar Learning Channel. And today we are tackling the March 2021 SAT calculator section, which I'm so excited about. I haven't done one of these in a while. And again, I can't live stream for the time being, so I am uploading these as finished videos. This is going to be the same type of feel. I'm doing it for the first time in real time. And that's it. And I can't wait. We're super excited to check this test out. This is the most recent SAT that was given. So as per usual, we're going to set the timer at 55 minutes, which is the allotted time given for this test. And we also have the calculator queued up if need be, as this is the calculator section. We're going to take it from there. All right, here we go. We are going to start in 3, 2, 1. Let's go. A sample of water was taken from each of 10 different locations, and upon the pH of each sample was measured. The measurements are summarized in the frequency below. Okay, so we've got one measurement in this range, two measurements here, 4 measurements here, 3. Okay, how many samples have a pH of 7.4 or greater? So it's going to be this zone right here, which would be 7, 4, and 3, right? And that's it. Number dos. In 2015, the city of Miami had a population of 441,000 people in an area of 36 square miles. What was the population density in people per square mile? And the per, I always say, is like a division symbol. So what are we doing? We're doing the 441,000 people divided by the number of square miles, which is 36. Calculator time, 4410. Oops. Well, we could probably estimate it mentally, but let's just roll with it. 36, 12, 250. Boom, done. Numero trace. Ooh, little, what's it called? Box and whisker plot. Metropolitan, these keep popping up more and more for some reason. College World must be loving these. The Metropolitan Museum of Art has plates on display from the Roman Empire and ancient Greece. The box plots, Roman Empire, ancient Greece. Okay, and this is diameter of something. Summarize distribution of diameters of all museums' plates. Oh yeah, plates. There we go. How does the median diameter of the plates from the Roman Empire, median in a box and whisker plot is that middle line. How does the median diameter from the Roman Empire compare to the median diameter of ancient Greece? So box and whisker plots, a couple things you got to know. This is the lowest and the highest value, min value, max value, min value, max value. This is the interquartile range, lower quartile, upper quartile, and that's the median. So if you know that, you're pretty good. And then let's see, Greece would be G. So G is bigger than R. Boom, done. Number 4. Oh, it did say median, right? Yeah, it said median. Okay, number 4. The combustion of glucose releases energy. The ratio of grams of glucose combusted to kilocalories of energy released of grams to kilocalories. Grams to kilocalories. I'm already seeing a nice proportion being set up here. Ratio of grams to kilocalories is 12 to 45. How many grams of glucose? Notice how I label, right? We have unknown grams of glucose to make 85.5. We got a proportion, cross multiply to solve. 45x equals 12. Whoops. 12 times. Got to make sure I type in this correctly. So I'm going to double check before I hit enter. 12 times 85.5 is 1,026. Last but not least, we divide both sides by 45. And we get 22.8. Boom, done. Should have probably guessed it's about double. I could have done that without the calculation, but it's all good. You know the general method, and you just roll with it. You don't question it. And that once you get in that rhythm, yeah, maybe it took me an extra 5 seconds, but then I didn't have to think about, hey, should I approach it a different way? I just go into autopilot, and that's what I want for you guys. The function f is defined by this. What is the value of f of 3? So plug and chug. Know your function notation. That's 3 squared minus 7. That's 9 minus 7, and that is 2. Make sure that I didn't make any mistakes. F of 3, 9, 7, boom, done. 6. The probability of an Go back to the timer. The probability of an unfair coin landing heads up is 0.6. Oh, it's unfair because it's more likely to get heads than tails. Otherwise, it should be 0.5. A student tossed this coin into the air 9 times. It lands tail side up 5 times and head side up 4 times. What's the probability the coin will land head side up? And it's 0.6. It doesn't matter what's come before. These are independent. That's weird question. I've never seen a question like this on the SAT before. Very interesting, but this is testing the fact that it's an independent event. So the previous flips are irrelevant. Very interesting problem. 7, frequency data set. Histograms, 0 to 10, 2. They're identical except for this little guy right here. Interesting. Show the distribution of dataset A and B respectively. Dataset B is the result of removing the outlier from data. Okay. Next thing is true about the means. Okay. The mean of dataset B has got to be lower because they removed these high values, these outliers. The mean of dataset, they're not the same. Did I say A is greater than B? The mean of dataset A is greater than the mean of dataset B. Boom, done. Mean. Oh, wait a minute. Yeah. Because they said they're identical. Dataset it's the exact same. Even though we don't know the specific values, if we didn't know the values, that'd be different. But these are identical, is what they're saying, even though we don't know the specifics, because they just chopped that out. So the mean of dataset A has to be bigger than B. All right, 7 or 8. Hammy drove a car from West Union, Minnesota through North Dakota. Here, let's zoom out a little bit. Hammy drove a car from West Union, Minnesota through North Dakota mile segment. Total distance travel each day is shown. So from here is 120, then 360, then 120. Got it. The distance d in miles Hammy drove as a function of time. Since she started as mile by the equation d equals 60t. So it looks like she's going 60 miles per hour. Distance equals rate times time, right? According to the model, what distance in miles had Hammy driven 3 hours after she started driving? Plug 3 in here. 3 times 60 is 180. Boom, done. 9. What interval, let's zoom back in. What interval represents all values of t during which Hammy drove in, what interval represents all values of t which Hammy drove in North Dakota? Got it. So it looks like this was 2 hours, because if she's going 60 miles per hour, that is 120 miles, 60, that's 2 hours. And then that's 360 miles. That would be 6 hours. And then here would be another 2 hours. So she's driven a total of 10 hours. And then the time in which she's in here would be when T is from 2 to 8, right? Because when it's at 8, that's 480. That would be right at the tail end of this. So she's in North Dakota from hour 2 to hour 8. And that's it. All values of t during which, North Dakota, boom, done. Numero 10. Okay, now we're on to a new problem. It's not the North Dakota scenario. The graph shows the number of algae cells grown during millions of cells per milliliter d days after the start of an experiment. Between which 2 days was the growth rate in millions of cells per milliliter per water of the algae the greatest? Between 5 and 6. See, because it jumps the most. Right there. Nice, straightforward. Nothing even comes. 4 and 5 is pretty good. 7 and 8, nada. 9 and 10, no way. Okay, let me just make sure I didn't misread it. Growth and rate. Yeah. Dunzos, interpreting a nice, that's a logistic function, it looks like. Not that you need to know that. 11. A local restaurant gives teachers a 20% discount on all their meals. If a teacher pays $14 for a meal, after the discount was applied, what was the... Okay, so a local restaurant gives teachers a 20% discount. If a teacher pays $14 for a meal after the discount, so that's a 20% discount, so it's 0.8 of some price equals 14. What was the price of the meal before? So I'm putting it in an equation because that's how I like to do it. So 80% of some price is the 14 because that's after the discount. So to get the original price, I just now divide by 0.8, just isolate, and we're good to go. We'll use a calculator since we can. And we get 1750. Boom, done. Numero 12, amount of water in 80 bottles. The frequency table shows the distribution of the actual number of fluid ounces of water in a random sample of 80 20-ounce bottles. Okay. So that's going to add up to 80. Bottles are only sold if they contain at least 19.8, no more. Wait, what? Okay. So these ones are not sold. I shouldn't cross it out, but, and then these ones wouldn't be sold too. So these are no-go. I'll do something like, I don't know, something like that. And then the proportion of bottles that can be sold is the same for sample and the 16,000 bottles. How many of the 16,000 bottle, okay, cannot be sold? So we say, or let's say not sold total. I'm setting up a proportion. So this is how I'm going to do it. So in this sample size, I've only got 2 bottles out of 80. Just make sure it's adding up to 80. Don't need to, but why not? 22, 53, 67, 70, 78, and 80. So 2 can't be sold out of a total of 80. How many can't be sold out of 16,000? We could simplify to 1/40th, if whatever, then it's that. So it's 40x equals 16,000. We can do this mentally if we want. It's totally fine. We just cancel, cross off a 0. 1,600 divided by 4 is 400. Now let's do a gut check. Does that make sense? If I do 400 bottles, so it's like, yeah, it's 1 out of every 40. So 4 out of 1,600, sorry, 1 out of every 40, 4 out of, 1 out of every 40. So that's 4 out of every 160, 40 out of 1,600, 400 out of 16,000. Gut check complete, we're good, 13. For the linear function f, the table shows several values of x and the corresponding values of f. What is the y-intercept in the xy plane? Okay, so it's a linear function. Let's calculate the slope by subtracting down. These are really y values, right? So 14 minus 8, which is 6, over -4 minus -2, which is -4, plus 2, which is -2. So the slope is -3. Then we can use point slope. Let's choose any coordinate. Let's choose that one. Y plus 7, because y minus that, equals slope times x minus that guy, which is 3. And we want the y-intercept. Boom, boom. Let's put it into slope-intercept form. Equals y plus 7, subtract 7, subtract 7. Y equals -3x plus 2. So the y-intercept is dose, 0, 2. Should we double check? How can we double check? Okay, I'll put it in here and let's just make sure the slope would be 2. 14 minus 2 is 12. -4 minus 0 is -4. 12 over -4, -3. Boom, done. Number 14. When a buffet restaurant charges $12 per meal, the number of meals it sells per day is 400. $12 per meal. The number of meals it sells per day is 400. For each 50-cent increase, price of the meal, the number of meals sold per day decreases by 10. $12 per meal. The number of meals it sells per day is 400. So it makes 48. So it makes 4,800 when it does that. For each 50-cent increase to the price, the number of meals sold decreases by 10. What is the price per meal? Okay. We could plug and chug, or I could set up a quadratic, and I am thinking we're going to do a quadratic. And find the max, or is there a... Oh, I could also just plug and chug. I could test out all these options. Let me think about it for a second. Because if I set up a quadratic, I'm just going to test it. Okay. So this is $16. So that's 8 increases. So this is, this would be 8 increases. You see what I'm saying? Because it's $4 gone up. This has gone up by $8. That's 16 increases, which is, it decreases by 80, decreases by 160. This is $8, which is, I'm sorry, this is $12, which is 24 increases, which drops by 240. And this is 28, which is 16, so that's 32. So it loses 320. I hope that makes sense because, again, goes up by $4. It's 8 50-cent increases. Okay. So what we can do is we can say instead of 400, we're selling 320. Instead of 400, Instead of 400, we're selling 240. Instead of 400, we're selling 160. And instead of 400, we're selling 80. Okay. And now we can calculate it. So we have 320 times 16 equals 5120. Then we got 240 times 20, which is 4,800. Times 20. I already know the answer because it's got to be 5. It's not going to come bigger than that. 4,800. This one is, we should say minus. This is 160 times 24. Yeah. And then this one is 80. There's no way. 80 times 28. That's 2240. It is A. All right, next. 15. The scatter plot shows a relationship between two variables, x and y. A line of best fit is also shown. What is an equation of the line of best fit? Okay, first of all, we need a positive slope. Goodbye, goodbye. You see how they flipped it? They moved it around, so those negative slopes are out. Now the question is the y-intercept 3.7 or 1.3? It's 3.7. Boom. And then just make sure that's a good slope of 1.3. I'd say let's choose 2 points. We're going up, that looks like 1, 5, and we're going up to 8, 14. So the slope would be 14 minus 5, which is 9, over 8 minus 1, which is 7, 9/7. Yeah, that's definitely closer to 1.3. It's not 3.7. All right, that's just verification, but we already knew. 16, for the linear function f of 2 equals 10. That means 2, 10 is a coordinate because if that's the x value, that's the corresponding y value. The graph of y and the graph of y of fx in the xy plane has a slope of 3. Boom, point slope. Let's do it. Y minus 10 equals the slope times x minus 2. Just throwing these guys in there like that. That's point slope. And then y minus 10 equals 3x minus 6 because they seem to have it in slope-intercept form. Add 10 to both sides. Y equals 3x plus 4. And we're good to go. Next, and just make sure if I plug in 2, I get, 10. Yeah, none of them out. I didn't even have to do that. I could have just been like, oh, man, silly. I could have just been like, these are out because they don't have a slope of 3. I didn't misread this. It was too easy, it seemed almost. Which equation to find? Yeah, so those didn't have a slope of 3. And then this one's out because this will have a y-intercept of 10, not 2, 10. So, yeah. Didn't even have to do all that. 7x plus 21. Okay. This is one where they try and watch. You got to be careful. Don't solve for x. Remember, solve for x plus 3. And there's a shortcut here if we want, but let's not even do it. Let's just wait. So if I divide everything, I'm going to do the shortcut. If I divide everything by 7, watch what happens. It's x plus 3 equals negative 2/7. And you're done. That's all you're trying to solve for. Now, I just want to show you something that if we solve for x, if I subtracted 3, I'd get, let me see, negative 2/7 minus, oh no, they don't have the answer. Oh, I was wrong. Okay, so I thought they'd have this answer there, the value of x, for people who would be like, oh, I'm going to solve for x, but they didn't. So that's actually pretty cool because you would definitely catch your mistake if you did that. 18. The solution of the given system of equations is xy. What's the value of 3x plus y? Got it. Okay, again, circle that guy. We don't want to mess this up and solve for x or y accidentally. So what I'm going to do is I'm going to do elimination, multiply that by 2. I get x plus 2y equals 10. 4x minus 2y equals 10. Combine, cancel. That's 5x equals 20. X equals, divide by 5. X equals 4. If x equals 4, 4 plus 2y equals 10. Subtract by 4, 2y equals 6. Y equals 3. So we want 3x plus y. So 3x plus y. That's 12 plus 3 is 15. And done. 19. An advertising agency guarantees that its services will increase website traffic by 3.5% compared to each previous week. Which best models the guaranteed traffic? Okay, increasing exponential. That's it. The reason why it's obviously not decreasing, it's increasing, The reason why it's not linear is because if it was 3.5% compared to like the first week, then it'd be a set amount every time. But this is 3.5% compared to each previous week. So let's say we have 100. Now we have 103.5. Then it's 3.5% of 103.5. So it's actually growing exponentially, because that growth amount keeps changing and increasing. Scatterplot shows a data set of 11 points and a line of best fit for the data set. For how many data points is the Y value predicted by the line of best fit greater than the actual Y value? Let me just read that again. For how many data points is the Y value predicted greater? Okay, so basically, where's the line of best fit above the points? That's what it's asking, because we're saying the Y value of the line of best fit is going to be greater than the points. So I'm going to count them like this: 1, 2, 3, 4, and 5. Done. Because the points are the actual values. 21, Dana's riding in a 100-mile-long bicycle race. The function defined by this models the number of miles that Dana's remaining X hours after she starts the race. So obviously she's going 18 miles every hour, right? Because if it's 1, she's knocked off 18. 2, knocked off 36. What is the best interpretation of f of 2 equals 64? This means, again, function notation, 2x is hours. So that means at 2 hours, she has 64 miles left, because the function represents number of miles remaining. Nope. We already know she's riding 36 miles. Nope. Nope. Yep. 20 dose. Oh, yeah, geometry. All right, so again, first of all, if these are 29 and 54, 29 and 54, these two triangles are 100% similar. We don't know if they're congruent, but they're similar. And this remaining angle is going to be the same, which means, should I put it in 70, 83, so 83, so it's 97. Which of the following statements is sufficient to prove triangle? Oh, and we need to prove they're congruent. The length of EF is 10. Not sufficient, because I need some relationship between these. We need just one side. I know all the angles are equal. Like, as long as I know one pair of sides is congruent, we're good. The measure of, nope, we already knew that. The length of BC is equal to EF. Boom, done. The measure of BAC is 8. Now, we already knew that. But, yeah. How many solutions does the equation have? All right, none. Anytime we have an absolute value equal a negative, it's impossible. Because how are you going to get an absolute value to equal negative? Everything that comes out of here is positivo, so it doesn't fly. 24. Solutions quadratic above are A and B. What is the value of A plus B? We're going to show you a little shortcut here. The sum of the solutions of any quadratic is negative B over A, which is, that's A, B, C, negative 1 over 3, boom, done. But since I know I'm doing good on time, I'm going to show you why that's true. If you want to do it the old school way, just do the quadratic, because I don't, wait, are these factorable? Actually, I think it is factorable. Huh, interesting. 3x, x, 1, 2, positive, negative. Because that'd be 3x squared, 3x negative 2x, positive x, negative 2. So my two solutions are negative 1 and positive 2/3. Negative 1 plus 2/3 is negative 1/3. Either or. In the figure shown, point O is the center of the circle. Cool. One vertex of the square lies on the circle, and the opposite vertexes. Yeah. The area of the shaded region is that. What is the perimeter of the square? Yowzers. Okay. What I need here, sometimes this gets a little funky. Yeah, why does it always default to this weird curved line? I'm still trying to figure out Miro, but it's great other than that, but sometimes a little strange. Okay, so we got a straight line. I know I need that because that's gonna be the radius. We always want to figure out the radius in any type of circle hybrid problem. So the area of the shaded region. So whatever. So let's call this R. So pi r squared. Oh, wait a minute. The radius is 6. This is such a weird problem. This represents the area of the circle. This represents subtracting the area of the square. That means the area of the square is 18. So the radius is 6. And then this is x, and we need the... So now, it's, by the way, this is a square. So this is a 45, 45, 90, right? So to get the side of that, we divide, because, okay, remember a 45, 45, 90, and this is on the SAT booklet. You can look this up. It's right there if you forget. But this side times the square root of 2 gives you the hypotenuse. So if I divided by the square root of 2, I would get x. So that right there is one side length. And to get the perimeter, I multiply it by 4. And that's... Oh, and we can double check this, by the way. If that's correct, that should give you a value of 18. And watch this. 6 square root 2 times 6 square root 2 equals 36 over 2, which is 18. So we know that's right. And this becomes 24 over root 2. Of course, they don't have that because they've rationalized the denominator by multiplying by root 2, multiplying by root 2, and we get 24 root 2 over 2, which is 12 root 2. Boom, done. 26. Which of the following is equivalent to the expression blah, blah, blah? Okay. Wait a minute. What's the best way to do this? I'm just going to factor it, I guess. I don't really know. This is weird. X squared minus 4. Yeah. So x squared minus 4, because that would be x to the 4th, negative 4x squared, that's negative 8x squared plus 16. And then factored again, those are difference of squares, x minus 2, x plus 2, x minus 2, x plus 2. And then these guys pair up, and these guys pair up, so it becomes x minus 2 squared, x plus 2 squared, which is this guy. So 1 is definitely in the zone. Well, of course, now it's going to come down to whether it's 1 or 2. And then this, I believe, is the same thing. So let's see if I can verify that. Hold on. What's the best way to do that? Okay, I know what wait a minute. Yeah, it's the same thing because it's this. You see? Because x squared minus 4, and here's another way we can verify it. I already know it is, but just to show you, if you want to do it, you could FOIL it out. X to the 4th minus 4x squared, which is minus 8x squared, and then plus 16. FOIL. Yay, 1 and 2. 27. Each year, the value of an investment. Each year, the value of an investment increases by 2.5% of the previous year's value. The initial value of their investment was 500. Okay, hold on. Equation gives the, so it's x years. Okay, so it's going to be initial value times 1 plus 0.025 to the x power. 500, because it's increase, right? Yeah. 1.025 to the x. Boom. This will be a 25% increase. This will be a 250% increase. This will be a 75% decrease. It's very interesting, by the way. I do highly recommend writing out the equation as opposed to looking at these and be like, which one makes sense? Because I feel like you go down a potentially more confusing path if you do that. Now, if you're totally clueless, sure, go through the answer choices and try and figure out which one makes the most sense. But how many solutions? Another thing you could do, by the way, I forgot, a great backup method you can do in this case is like, you know that you can calculate 2.5% of 500 and be like, oh yeah, after the first year, I should have, you know, whatever, 2.5, what is 2.5%? I don't need a calculator for this, honestly, I shouldn't have done that, but that's $12.50. So for which one, when you plug in 1, do you get $512.50? And it's this one. Boom, right? $512.50. So you can verify kind of that way when it comes to these ones. How many solutions does this system have? Well, I think what I'm gonna do is, yeah, it looks like infinite because I think they're the same equation, but let's just solve it. So I'm gonna multiply the top by 12 and then use elimination. So it's 60x minus 12y equals 108. And this is negative 60x plus 12y equals negative 108. Obviously, if I multiplied this one by negative 1, you'd see they're the same equation. If they're the same, they have infinite solutions. They're overlapping lines. Numero 29. Bridges have spaces between their sections to allow for expansion and contraction caused by temperature variation. The space is known as the gap width. The size of the gap width in T inches is a linear function of temperature T in degrees Fahrenheit. For a certain bridge, the gap width is 2.875 at 40, 1.875 at 100. Just find defines the relationship between temperature and gap width. Okay. We got to plug and chug here. Oh, wait. No, we don't. We got two coordinates. So the temperature is the x, 2.875 is the y, or the width. And then this one is 100, 1.875. Okay, and I can calculate the slope by just subtracting down, right? This minus this is 1 over that minus that is negative 60. So the slope should be negative 1/60th. So these guys are out. That has the slope upside down. And why did I choose the gap width to be the y? Because look how they set it up. So the slope's got to be in that format. And then 40 degrees, it's got to be this one. Here's why. If I plug in 40, it's going to zero this out, and I'm going to get 2.875. Here, if I plug in 40, I mean, I guess I could try it, but I'm pretty sure I'm not. No, because this whole thing's going to be negative plus another negative, so it's going to be like a negative value, and that's wrong. Now, just for fun, we can plug in 100 into this equation, and I'll prove to you that it's right. We could do 100 minus 40, which is 60. Or I can do this without a calculator. 60 times negative 1/60th is negative 1. Negative 1 plus that is 1.875. So double verification. And 30. The number of books in a library increased by 30% from here to here. 2002 to 2014. 30% increase. There were X books in the library in 2002. Which expression represents the number of books in the library in 2014 in terms of X? By 30%. 1.3X is the answer. Okay, that's it. Now, if you're not sure about that, test it out, right? If you have 100 books, if this is the amount in 2014, it would be 3,000. That makes no sense. That's not a 30% increase. It didn't say, wait. Yeah, it didn't say per year. So 30% total. This one would give you 30. So it'd be too small. This one would give you 13,000. So that's not a 30% increase. This would give you 130, and that's 30% of 100. Boom, done. All right. 31. Now we're on to the free response. 22 minutes to go. We're in great shape for 8 questions. In a survey of 240 television viewers, 3/5, let's calculate that. 3/5 is 0.6. 0.6 times 240 indicated that they like comedies, and some indicated that they do not like comedies, and the rest did not respond. If one of the 240 viewers is selected at random, the probability is 1/15 that the viewer did not respond. So 1/15 of 240 is 16. So 16 did not respond. How many of the 240 viewers indicated that they do not like comedy? So that's the remaining. So 144 plus 16 is that, and then 240 minus that is 80. Makes sense? So 80, we already know that's 16. Let me just make sure. 15, 150 plus, I'm just doing it mentally now. Yep, 16. If I did it again, yeah, okay, I think I'm pretty good on that. Next, just making sure I don't make a silly mistake is all I was doing there. What is the y-coordinate of the y? What is the y-coordinate of the y-intercept of the graph? So what is the y-intercept? That is when x equals 0, right? So I'm going to plug 0 in and solve. 3 to the 0th is 1, plus 9 is 10. Boom, done. Triangle ABC is similar to DEF. ABC is similar to DEF, where angle A corresponds to angle D, which makes sense. These guys correspond. What is the value of cosine of f? All right, here's the deal. Since these are similar, cosine of f is the same as cosine of c, okay? So what is cosine of c? It is adjacent over hypotenuse, because we're talking relative to c, adjacent is next to it over hypotenuse. 24 over 18. You don't have to reduce it necessarily. I'm going to reduce it just for the heck of it. Divide top and bottom by 6, and we get 4/3. And we're good to go. Just make sure I didn't make a mistake. Cosine of f. So A to D. Oh my God. What am I doing? Oh, I just almost, that is ridiculous. That mistake I literally just almost made. See, insane. Okay, sorry. I said this was the hypotenuse. I don't even know it's adjacent over hypotenuse. First of all, cosine and sine can never be greater than 1. I don't know what just happened. I totally blanked. But anyways, adjacent over hypotenuse. 24 over 30. Divide both by 6, and we get 4 over 5. Wow. Okay, let me just make sure one more time I didn't make a mistake. Was if I have cosine of f, cosine of c. 24 over 30. 4 over 5. Okay, cool. Done. Geothermal power capacity for 9 countries in 2010. The graph shows the power capacity for the 9 countries that had the greatest geothermal power capacity in 2010. What was the capacity in megawatts of the country? Got it. Median. All right. So let's order these. I'm not going to rewrite the values. I'm going to say this is the smallest, next smallest, next smallest, next smallest, 5, 6, 7, 8, 9. So now I've ranked them from least to greatest. Of course, the median value is the middle in between from 1 through 9. It's Italy. Oh, it said, what was the capacity? So 863. Just make sure I didn't make a mistake. 1, 2, 3, 4, 5, 6, 7, 8, 9, 863. So capacity in megawatts. And these are in megawatts. Yeah, it's in megawatts. Just making sure I'm not making a silly mistake. We're good. 35. Line L is shown on the XY plane, and the point with coordinates 2C is on the line. There's 2 comma C is on the line. What is the value of C? Oh, okay. It's a decimal, or a fraction. Okay, I was like, what? How do we do this? But here's how we do it. All right, so first of all, this is we can put it into slope-intercept form because it's got a y-intercept of 4 and a slope of negative. It goes down, actually, it goes down 4 across 5. Negative 4/5 x. You see that? Down 4 across 5. Positive 5, and, negative positive. So negative 4/5. Then we want to know what is the C value. So now I can plug 2 into this equation and solve. So 2 times that is negative 8/5 plus 4. I'll get common denominator because 4 is the same as 20/5, right? 20 divided by 5 is 4. And so then we get 20 plus negative 8 is 12/5. Or you could say 2.4. And it looks like 2.4, so we're pretty good. This is a very interesting and difficult test. Very interesting. Where's 36? Okay. The table gives the typical adult weight ranges and lifespans for African Asian elephants in the wild. Typical minimum Asian elephant. Typical maximum. So 7. So these guys are run bigger, the African versus the Asian. 7 tons. I think a ton is 2,000 pounds, right? Typical lifespan said, wow, I wonder if that's true. That's pretty good. Based on the table, what is the typical minimum? The typical minimum of an adult African elephant. Typical minimum of an adult African elephant in the wild in pounds. African. So 2.5 tons. But they want it in pounds. So this is in tons. I'll do it like standard dimensional analysis. So then we say 1 ton equals 2,000 pounds. Then you cancel the tons. So it's basically 2.5 times 2,000, which is 5,000. To be absolutely safe. This is unnecessary, but why not? All right, cool. Based on the table, the typical lifespan of the African elephant in the wild is P% greater than typical lifespan of the Asian elephant in the wild. So 70 is 1 plus, since that's in a percentage, I'm going to represent what they're saying, 1 plus P over 100 times 60. Okay, I'm going to get back to why I did that in a second. Is P% greater than the typical lifespan of the Asian elephant in the wild? What's the value of P? Got it. And disregard this. Okay, disregard the percentage sign. So what I'm saying is, when we're increasing, we're saying something is 20% greater, right? So if you have 100, 120 is obviously 20% greater than that. So, but if I'm making an equation, how would I go from here to here? I'm multiplying by 1 plus that percentage that it's increased by, the 20%. So it's 1.2 times 100 is 120. So I'm doing the same thing here, but again, I have to convert it to its decimal equivalent. Point is I got the equation, and now all I have to do is isolate. So I do 70 divided by 60, which is 7/6 equals 1 plus P over 100. Then I minus 1 from both sides. By the way, minusing 1, that's like minus 6/6, right? So 7/6 minus 6/6 is 1/6 equals P over 100. Cross, cross. 6P equals 100. Oops. And then, wait, does it? This is going to be 100 over 6. I know that has a repeating decimal, which is weird. Okay. I could also say I probably could enter this as 50/3 or 16.7. Sometimes I'll even take 16.6, but it just feels weird to me. Hold on. Am I doing the right values? Lifespan of African elephant is 70. I was hoping for a nice whole number. I think this is still probably right, but see that I don't like that. Based on the table, the typical lifespan of African elephant is P% greater than the typical lifespan of an Asian elephant. It is, so that's 1/6. 1/6 is 16.666 repeating. What is the value of P? Yeah. I'm rolling with 50/3. I'm just going to write 16.7 as the other option, just so we have it down when we're checking the answers. All right, 38 for the final one, 11 minutes. The table shows several values of x and the corresponding values f of x. The function f is defined by f of x equals mx plus b, where m and b are constants. What is the value of b? So this is obviously a linear equation. So here's what we're going to do. We're going to first calculate the slope by subtracting down, as I like to do. That's my version of the slope calculation formula. So 106 minus 151. Don't need a calculator, but I'm just going to use it just to be safe. Don't want to make any mistakes. Negative 45 over 2 minus 3 is negative 1. So the slope is 45. And now let's do point slope. Y minus 106, I'm choosing the top coordinate, equals 45 times x minus 2. And we want the b value, which is the y-intercept. So if I put it in slope-intercept form, I'll get it. 45x minus 90 equals y minus 106 plus 106 plus 106. Y equals 45x plus 16. And 16 is the winner. Okay. By the way, I could have gotten to it also. You see the jumps are by 45. Another way I could have found the y-intercept is like every time it goes up by 45, it goes up by 1 here. So to get y-intercept, it's when x equals 0. That's what b is. So I could have jumped down by 45 and 45, which is jumping down by 90. If you jump down by 90, it also gives you 16. All right, we are done, ladies and gentlemen. Let's stop the clock. Now, of course, if you have extra time on the real thing, you're not going to do what I just did. You're going to actually double check all your work and do all that stuff. But it's all good. We are going to check the answers. All right. Let me zoom out. And let's get the red pen of justice. And let's see how we did. Hard test. And it feels different than previous tests. They're definitely, it's evolving for sure. I can definitely say that. The test is definitely evolving. So we got D, B, A, C. 5 is C, C, B, D. C, C, B, D. 9 is B, 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 C. B, B. Thirteen is C, A, A, D. C, A, D. 17 is D, D, A, A. D, D, A. 21 is D, C, A, B. D, C, A, B. 25 is C, C, B, D. C, B, D. So far, so good. And 29 is A and C. Whoo! All right, we got all those right. Now we get to the free response. 31 is 80. 32 is 10. 33 is 4/5 or 0.8. 863, legend. 12/5 or 2.4. Both were acceptable. 5,000. I kind of glanced ahead, I'm not going to lie, and I saw the 53rds was correct, despite it being such a weird value. But they also accepted, as I thought they would, 16.6 or 16.7, which is pretty cool. And then 16 for the win. All right. That was a very interesting test. A couple things I want to point out is that this was interesting. I hadn't seen a problem like this before, but it wasn't too bad to break down and interpret. That one, I almost made a really silly mistake on 33. Like I said, I keep noticing these box and whisker plots. They're in my critical concept videos, so make sure you get that. This was a very interesting one, very, very tricky. But once it was broken down, you can see it wasn't that bad. You just have to recognize that that's the area and that's the area of the square. You're subtracting the two, right? And what else was kind of a little weird? This one was interesting. This one was very interesting because this is like if I wanted to come up with a quadratic to sort of like represent this, that's kind of like the standard way to do it, but you you know, you didn't need to. You could plug and chug. And I was having a little bit of a moment, like trying to be like, okay, how do I come up with the quadratic for this? But that's typically the way you do it. You come up with a quadratic and then you find the vertex, because it'd be like one of those and the vertex would be the max, and then that would be the solution. That was interesting. I have not seen a problem like that. I mean, maybe I have in the free response, I think, but not in multiple choice like that. Yeah, otherwise pretty standard. This one was interesting. This one was pretty interesting too, chopping off the outliers. But I mean, there has been stuff like that before. So all in all, this is one of the hardest ones I think I've seen in recent times. So if you did take the March SAT, good on you. It was a difficult one. I don't know what the curve is. I don't think that has been released publicly, but I bet you it was fairly generous just because of the difficulty. I hope you enjoyed the video, and if you did, please click that like button. And if you want to see more from the Scalar Learning channel, make sure to click subscribe. Also, if you want to check out my Math Puzzles channel, you can do that as well. Just search Huzaifa Math Puzzles, and you can find that channel. It's pretty fun. We're doing new math puzzles pretty much every week, sometimes multiple per week, and just to hone your skills as you continue on your journey in life and just try and be better and faster and all that good stuff. Thank you guys so much for joining, and I'll see you in the next video. Take it easy.